Ciao friends! In this video, I want to optimize with you a DAX expression that computes the number of working days between 2 days. We will start from the simplest formulation of this calculation. It's very simple and you can find it on a lot of web articles, including ours. But then we will try to optimize it and make it run faster using a technique known as cardinality estimation. We will basically analyze what the formula does, understand where it is spending time, and then try to reduce the number of iterations it performs in order to speed it up. Keep in mind, I will not be able to teach you all the details about how to optimize a piece of DAX code. We have a full training about that. But you can use this video more like a test. You can watch it and either you find it utterly boring, meaning that optimization is not for you. On the other hand, if you, like me, find the topic fascinating, then we have tons of articles and videos at SQL BI that you can watch in order to learn how to optimize DAX code and obtain always the best out of your engine. So, if you are curious about that, follow me and we start by first understanding what we want to compute and then perform the full steps of optimization. Let's get started. This is the report that I want to produce. It contains, slicing by year, the average delivery working day, so the number of working days that are needed on average in order to deliver our good. I'm not computing the number of days, but the number of working days. Let's start by understanding the difference. In Contoso, we have for each order the order date and the delivery date. Now, I tweaked the data a bit in order to have longer delivery time, because otherwise the numbers would be really too small to analyze and that would be not so interesting. So I basically added a year to all the delivery dates to have longer delivery periods. So this order was placed on the 1st of January 2007 and was delivered on the 7th of January 2008. I want to compute the number of working days between these two dates. And in order to compute that value, I will scan the date table and I will count the number of days that are in between the 2 days and that they are working days. I'm going to consider a working day any day that is from Monday to Friday. So I will skip Saturdays and Sundays. Let's start by looking at the code that computes my measure. The code is here, average delivery working day, and it is iterating over the sales table. For each row, it computes the number of days, applying two filters. The first one says that the dates need to be between the order date and the delivery date. So out of the entire date table, I take only the dates that are in between the order date and the delivery date. And I have another condition that says that the day of the week number needs not be neither Sunday nor Saturday. 1 is Sunday and 7 is Saturday. So these two conditions restrict the date table, showing only the dates between the order date and the delivery date and that are neither Saturday nor Sunday. I basically count them and then I average everything. You can look at the result here, just putting the result here. You see that we have 266 working days, 267, 268 again, and so on. So this is the number day by day for each individual order, but I'm interested in looking at the average over the entire year. Now, the thing is, we want to optimize this code. We want to make it as fast as possible. And to do that, we first need to understand where the complexity is. Moreover, we also need a baseline. We need to understand what is the current speed so that when we write different versions, we will be able to check if it runs better. But let's start from the complexity. No, actually, let's start from the baseline. It's likely to be better. To do that, we need to use DAX Studio and start writing some code. We want to replicate the same query that we had in Power BI, but this time using DAX Studio. So let me write evaluate. We want to do a summarize columns by date, calendar year, and we want average how do we call it? Average delivery working day, which is our average delivery working day. Okay, let's format the code and add the spaces where needed. Now, I can now run the query, but before doing that, I activate the server timings because I want the first baseline, and I also make sure that I have clear cache and then run. So I can run the query, it executes, and now I have my first baseline. Let me zoom this a bit. It takes a bit less than a second, 980 milliseconds to run the query. 1 second of storage engine CPU, and most of the time is spent in the formula engine. You see that 84% of this 1 second is spent in the formula engine. So this is my baseline. It's the starting point. Whatever I obtain better than this, that is good. I just open another window because I want to keep these values ready here. And in the next window, we will start optimizing the code. Now, in order to optimize, we now need to understand where the complexity of the code is. To do that, we don't need specific tools. We just look at the DAX code and try to guess what the engine is going to do. So let's go back to the formula and see together where the complexity is. Average X is an iterator that iterates over sales. We know we have around 12 million rows in sales. So this iteration will happen for 12 million times. For 12 million times, we use calculate. Calculate count rows dates. Now, dates contains around 2.5 thousand rows. So scanning date to compute the number of dates. Okay, scanning date to compute the number of dates is not going to take a lot of time because it's a tiny table. But we have these dates between and these not. These are two filters in Calculate that need to be applied. Now, applying a filter is fast or slow depending on the size of the filter. A small filter is fast to apply. A very large filter, it takes a lot of time to be applied. So we need to understand the size of these two filters. Let's start from this one. This one is very small because the week number only contains 7 values, and we are just checking whether values are not, whether a value belongs to 1 or 7. So this is going to be very fast. This is a bit harder because this dates between iterates over data or returns the data, the values of data between the order date and the delivery date. And its size depends on the difference between the delivery date and the order date. The longer it takes to deliver, the larger this table will be. And this is the reason why I tweak the data to take at least a year to deliver goods. So this filter is large enough to give us space for optimization. So these dates between might be the problem. But if I have to compare 12 millions with 2.5 thousand and a few hundred rows, it looks like the problem is here. I'm iterating over 12 million rows, and for 12 million times, I'm doing this calculation. So what I want to do is author a different version of the same formula that instead of iterating over 12 million rows, iterates on a smaller number of rows. But what can I use instead of the values row by row? Well, I can look at the code inside my average X and note that it does not really depend on all the values in sales. It depends only on the order date and on the delivery date. So given the pair order date and delivery date, I know the number of working days, and I can use this number for all the sales that have the same value for order date and delivery date. If it happens that I have a lot of sales with the same values for order date and delivery date, I can reduce the number of iterations. Instead of 12 millions, I can iterate a smaller number of times. But how much smaller? Well, that I can evaluate. I can use DAX Studio here and evaluate the difference. I can evaluate the count rows of sales as a table. And I know that I have 12 million rows in sales. But what about the different combinations of order date and delivery date? I can do a count rows of summarize sales by sales order date and sales delivery date. Another parenthesis. Now this first part returns the number of distinct combinations of order date and delivery date. And if I run it, you see that I have 12 million rows in sales, but only 6.5 thousand rows in as different combinations. So if I reduce this iteration, that is gonna be much, much better. Now, I will reduce the number of iterations, but I also need to change the algorithm because I cannot just iterate on a smaller number of rows. The average made over 12 million rows is not the same average made over 6,000 rows because over 12 million rows, each combination has a weight, a relevance that depends on how many rows I have with that combination. What I need to do is move from a simple average, as I'm doing now, to a weighted average, where I weight each combination by the number of orders that I have. So I need to sum for each combination the number of orders multiplied by the duration and divide the total number by the total number of rows. Let's do that. We don't want this anymore. What I'm gonna do is I take my original query, I copy it here, and I also add the definition of average delivery working day, so we can rewrite the query and look at different performance. So let me go here, add the definition of add delivery working days, then we can get rid of that. This is the current definition. I'm actually not interested in nearly anything here. Let me see. It's easier to rewrite everything. So we need to write a weighted average. First, we need the total number. Let me use the same variables that I use in the article. I called it number of all orders, number of all orders, which is count rows of sales. This is telling me how many rows are in sales. Then I need the weighted average value. So delivery, how did I call it? Weighted by number of orders. Delivery weighted by number of orders. And this is now a sum x. It's no longer an average x. I need to summarize sales by sales order date and sales delivery date. This is returning the combinations of order date and delivery date. For each one, I need another variable, number of orders. This is the number of orders that have this specific combination, and it's calculate count rows of sales. And then I need the duration. The duration that I called working days. Working days. It's count rows of, no, I use the same code that I used earlier. Calculate count rows of date. Count rows of date. Dates between sales order date, sales delivery date, and then not the date, working day or week number in 1. or 7. So this is the number of working days of the specific combination, and then I return the number of orders multiplied by the number of working days. And then I need to close my SUMX. So delivery weighted by number of orders now returns the multiplication of the delivery in working days times the number of orders with that specific combination. Last step in the weighted average, I need to divide one by the other. So I return the delivery weighted by number of orders divided by the number of all orders. Okay. Now, this version of the code, let me format the code. It does not work because there is an error somewhere. Dates between, yes, I'm missing date here. Let's see if it now formats nicely. It does. Okay, this way you can look at the entire piece of code. This version is much longer than before, but hopefully it will be better. Keep in mind that that's the hard job of optimizing code, is that you are never sure that the hard work actually pays. In this specific case, I honestly don't remember, so we need to test it. But if I don't remember, but this does not really pay. Let me run the query. We have our result. And so good for the result, but we want to measure performance. So let me enable server timings. Run the query, look at the server timings. Here it is. Okay, it's taking 797 milliseconds. Most of the time, nearly all the time, is Formula Engine. Now, what was the previous execution time? It was 900 milliseconds. Most of the time was Formula Engine. Now it's 700, 800 milliseconds. So we saved 100 milliseconds, which is not really a lot. Basically, this optimization didn't go very well. We reduced the number of iterations, but that didn't help us a lot. And that is curious. How is it that it is not so much faster? Actually, if we look at the previous piece of code, that is still calling the original working days that contained the 12 million iterations, you see that we don't see 12 millions anywhere in the queries executed by the storage engine. And we see numbers 657, this is the number, 2559 is the number of rows in days. What is this 6576, which happens to be also here? If you remember that, and if not, you can go back in the video, this is the number of distinct combinations of order date and delivery date. The engine was smart enough to look at our previous formulation. Let's take a look at our original formulation, is this one. And it discovered by itself that this code depends only on order date and delivery date. So it is basically computing the weighted average by itself, with no need for us to compute the weighted average. With that said, it was good anyway to compute the weighted average, because now we know that trying to optimize the outer iteration doesn't lead anywhere, because the engine already optimized it by itself. But can we do anything better than that? If you remember that there were two iterations, an outer iteration and an inner iteration. If we cannot optimize the outer iteration, we can try to work on the inner one. Let's look at the details. There. I need more space, so let's get rid of it. Now, where are the iterations? We have the outer iteration, the iteration on this summarize that we already optimized, and that was not bad. And then we have this inner iteration, which still has to iterate over all the working days. How can we reduce that? Well, the thing is, we cannot reduce it by a lot, but we can note that there are actually more working days than non-working days. On average, in a week, we have over 7 days, 5 are working days, and only 2 are non-working days. So why not counting the opposite? Instead of counting the working days, I can count the non-working days. That reduces the size of the table that I need to compute. And then instead of counting, I count all the days and I subtract the number of non-working days. The good thing is that I don't need to count the number of days, because to count the number of days between 2 dates, I can simply do a subtraction between the 2 dates. So I reduce the counting by changing the entity that I count. Let's do that together. I need to change this definition, and this requires kind of a lot of, not a lot of work, but we need to pay attention to a lot more details. We start with, well, we still need the number of all orders because we will still need to do a weighted average. But we prepare upfront a table that contains, how did I call it, non-working days. Non-working days. We define a variable that contains the subset of data that are non-working days. So I can use calculate table, values of date. I need to get rid of any filter on the date table because I have a filter with order date that might be restricting the visual that I have on dates. I want all of them. And then I want this condition that the day of week number, I messed up the formatting, 1, 2, 3, 4. No, that is fine. Okay, this needs to go a bit back. Now I'm computing the non-working days. So the condition is that the week number needs to be 1 or 7. Now I have my non-working days table. I still summarize delivery date. I count the number of rows. But instead of counting these dates, I count the non-working days, number of non-working days, where I filter out of the non-working days table all the rows where the date is greater or equal the order date, and at the same time the date is less or equal the delivery date. This parenthesis is not needed, this closes filter, and this condition goes away. So now I have the number of non-working days, and my hope is that by counting the number of non-working days, I reduce the number of rows that need to be counted, therefore the formula should be faster. I have no idea how much faster. Now I can no longer compute the working days because I have the non-working days, so I need a variable, another variable, number of working days, which is delivery date minus sales order date, and this is the number of days between the two, plus 1, because otherwise I would not count 1 day. And I also need to remove plus, no, I'm just checking. Yes, I need the plus 1 minus the number of non-working days. So in order to compute the number of working days, I start from delivery date minus order date plus 1. All this expression is the number of days between the two dates, and I subtract the number of working days. The remaining part of the code is the very same. If I try to run it, it doesn't work. I'm missing a comma here. And I renamed the variable, so I need to rename it also here. and it still does not work. Why not? Because this is not a filter. Number of working days is not filter, but it's count rows of this filter. Count rows of this filter. Okay. Let's look at the results. Okay, I know them by memory, so I already know that they are correct. And let's look at the server timings. Now it looks way better. Let me run it again so we have a clear execution time. It's 220 milliseconds compared with 918. So it's 5 times faster, which is good. So you see how cardinality estimation works. You try to guess where the engine is spending time. You look at the iteration. You try to estimate the time that it takes to execute some operations, and then with some creativity and some ideas, you reduce the size of the structure that the engine has to scan in order to compute their values. And at the end, after some trials, it pays off because you can obtain better results just by changing the values which are computed. So this version is already kind of better, and we can use this version of the code that counts the number of non-working days. Can we do any better than that? Actually, we can, because keep in mind that when it comes to optimizing a code, nothing beats pre-computing values. If you think about that, why do we need to compute every time the number of working days between two dates? Given two dates, if we knew in advance the number of working days between these two dates, then instead of computing, we can just search for the value and grab it. That's why what we can do is pre-compute a table that contains the order date, the delivery date, and the number of working days in between these two dates. Then, in the same code that we wrote here, we simply seek for the pair of values that are interesting. We avoid the calculation and we just use a lookup value function or a natural left outer join in order to grab the measure. I'm not going to write the entire piece of code with you because otherwise the video would be really, really long. Instead, let's take a look at the solution and then we measure the performance. Now, to look at the solution, we need to use another model where I already have the solution. Here it is. Here I created a table. Look at this table. Let me increase the font a bit. I called working day delta, where I use add columns over summarize sales by order date and delivery date. And by now you know that these are all the possible combination of order date and delivery date. And for each pair of order date and delivery date, I use the code that we use so far several times to compute the number of days which are in between the two dates and that are neither Saturday nor Sunday. These count rows tell me the duration in working days between the two dates. But the thing is, now this is a calculated table that I added to the model and I put here. You see, I have this table which is completely unrelated to the remaining part of the model, but already contains the values computed. Now that I have the table in my code, okay, here it is, I have a variation of the code. Let me format it so that we see a bit more of that. I compute the number of all the orders, then I summarize sales by order date and delivery date, only this time I save it in a variable. This doesn't change the value, but I need this step because in order to perform the joins, I will use this function, the natural left outer join, that requires the data lineage of columns to be the same. So I will need to change the data lineage of these columns. And in order to do that, I save that in a variable. Then I compute the day's duration. I select from the WD delta table, the calculated table we saw earlier, the order date, the delivery date, and the duration, but I use 3 tasks to change the data lineage to the same data lineage as sales dates. We have order date, delivery date, and here we have order date and delivery date. That let me use the natural left outer join function that will join these two tables based on the lineage of the columns. So here I'm basically taking the WD delta table and changing its lineage. Then I compute the delivery weight by the number of order, but I do that using a natural left outer join between these two variables. The result of the natural left outer join contains the order date, the delivery date, and already computed the duration. So by skipping the calculation, I just need to compute the working days, multiply the number of orders by the working days, and at the end divide by the number of all orders. I call this measure average delivery working day 3. Let's look at the performance of this measure. To do that, I need to go back to DAX Studio. Let me remove all the stuff we have wrote so far. And we measure the performance of average delivery working day 3. We went from 900 milliseconds to 200 milliseconds. This does not work. Why not? Oh, because yes, that was defined in a different workbook. So I need to add the measure. Define measure. We give the name later. Okay, sales average delivery working day 3. And yes, that's my bad. I also need to create the calculated table. So let me do that. I take the code of the calculated table from the workbook that already contains the solution, and we create the table here. So we go to modeling, new table. We create the table, check that it's there, WD delta. Yeah, you see we have order date, delivery date, and the duration of that specific combination. Now that we have the table, we can go here, format the code. Okay, reduce the font a bit. Hopefully, yes, that is still readable. So I now have my average delivery working day 3 that uses the WD delta table. And as I said, we went from 900 milliseconds to 200 milliseconds. Let's look at the speed of this query. That is way better. Now it's 58 milliseconds, and most important from point of view of the optimization, the time is nicely spent between the formula engine and the storage engine. 30 milliseconds of formula engine, 28 milliseconds of storage engine. So this version, which pre-computes the values, is by far the fastest. But also the previous one that was running in 200 milliseconds was not that bad. Let's draw some conclusion at this point. As you have seen, that was quite a long trip. We started from a simple formulation, then we tried to understand how the code works. We made some trials, not all of them worked. And that is totally normal. Whenever you optimize code, sometimes it works, sometimes it does not. This is part of the job of optimizing code. But when you reach the good level of optimization, you move from a measure that runs in around 1 second in the same calculation that runs in 50 milliseconds. That is 20 times faster. Way better, way faster. It will run for more users, so it's definitely much more interesting. As I told you in the introduction, this was a long trip, but it was meant to show you all the steps needed to optimize a measure. If you have code that you want to optimize, well, you can start to play with DAX Studio and try to understand all the details. But make sure to go to sqlbi.com, read the full article, download the file, and maybe just follow step by step all what I have done so that you get acquainted with the tools. Enjoy DAX!